You have a unique light signature that is you, but you're not really that color. You think that you're the color that you are, but actually that's just a reflection color. You have a whole nother spectrum of you that's the absorption. So let's take an example of hydrogen. This is what the spectral reflection of hydrogen looks like. So if you looked at, spectral analysis of hydrogen, it would have a color purple, another color that's more violet, and then kind of this bluish color, and then this light blue, and then this red pinkish color. That combination of colors is how we know hydrogen exists. So when we look in the outer space and we use a telescope that does this spectroscopy, and we could see across the entire cosmos, we know where hydrogen pockets are, where there's a high preponderance of hydrogen based on the color reflections that come out. That's how we know what something is. Like if you're looking at some material, you don't know what the material is, you can look at a spectral reflection analysis and be able to tell exactly what that material is just based on the colors that are reflected, the unique combination of colors that are reflected. Now you understand that you have DNA. Your DNA is a unique signature of you. There's never been another DNA like yours, and there never will be another DNA identical to yours. You have a persona, right, which would be these colors right here, your reflection, and then you have a shadow, the exact opposite. So all the colors that are used for the reflection are not part of the absorption. That's why you have blacked out lines here. So that means you have all the rest of the colors in the light spectrum that are not you. But what if those colors simply get projected back to you as reflection in the world around you? The mathematics of this is something called the Rydberg formula, and Niels Bohr, who was a famous Danish physicist in the 1930s and 40s, who worked closely with Einstein, he was more on the quantum physics side of things, he basically found that you could exactly predict, based on the frequency of hydrogen, its spectral emission of color. This is called the Bohr atom model. Mathematics of it is simply x at 1 over x. They used here lambda, so it's lambda and 1 over lambda. So you have this differentiation that would then tell you these specific nanometers of light would be converted directly from the spectral, or frequency rather, of hydrogen, based on the frequency of hydrogen, based on its 1 over x calculation, what its nanometers of light signature will be. These lines right here, so this is measured in nanometers, this is 400 nanometers, 500 nanometers, 600 nanometers. What we're really looking at is 1 octave of light, 89 octaves or 88 octaves of experience across sound. Thought at the very basis becomes sound, becomes microwave, it becomes infrared, becomes ultrasound, and then as it goes higher and higher, light is just the 55th octave above sound.